Hello, and this is going to be the second part of Intro to Geoscience. This one's going to be talking about percent error. This is something that I'm going to have my kids do periodically to actually keep them honest, to see how well their data is being collected and compare it to known values. We're probably not going to try to recreate the wheel in this geoscience class. We're just going to be looking at data that has been collected and is fairly well understood. But anyway, the whole idea is called percent error. Percent error equation is down here. Percent error is actually calculated by taking, that's way too big, by taking your data and subtracting the actual value from it, and then dividing it by the actual value, and then to get percent by multiplying it by 100. And we'll actually do this with this example. This is Mary sitting on top of her pedestal on top of a gold dome. This is off the main administrative building in Notre Dame University. You can see there's the ND right there. They looked into actually making this out of gold leaf, or gilding it out of gold leaf. Gold is actually something that's it's called malleable. You can actually take it in a hammer and flatten it out. Gold bars are usually 400 grams. I can do this with my pen. Don't know why I'm trying to do it with the mouse. Gold bars are actually about 400 grams. It's actually said that we could take 8 ounces of gold and we could actually hammer that out to be equal to about 1 acre. This is supposedly a little bit more than an acre because they would actually take, scratch that. What they would really be doing here is actually taking something about a pea size. Probably should draw that in green, and actually hammer that pea-size piece of gold into an acre. This is actually larger than an acre. They'd actually have to use 8 ounces. Let me show you what 8 ounces would look like. Cut a 400 gram bar in half and you have about 200 grams. Cut that in half and you'd have 100 grams. Cut that in half, that gives you 50. Cut that one in half, that would give you 25. Cut that one in half, you're down to now 12 grams. Cut that one in half and you have 6. Add a little bit more, and that's how much gold you would need to hammer out to cover this entire thing. Now, why am I using this? Well, this is Forest Park High School. This is where I teach. We're actually sitting right about here. I'm actually probably standing right there. We're looking at a screen right there, and a bunch of kids in between me and the screen. Okay, so what we want to do is, let's say we want to actually put this dome on top of Forest Park High School, and we don't want to use a gold-colored mineral. We want to actually use gold. Now, we wouldn't use solid gold because gold has gold is actually abbreviated with AU. Gold has a specific gravity of about 19.2, and what that basically means is it is 19.2 times more massive than an equal amount of water. So it has the density of about 19 grams per cubic centimeter, because water is 1 gram per cubic centimeter. Average rock, crustal rock, abbreviate rocks RX, has an average density of about 2.7 grams per cubic centimeter. So if you actually made this dome out of solid gold, let's say this is 3 goes into 19 about 6 times. This thing would weigh 6 times more than if we made it out of solid rock. So we can't do that. It's too expensive. It costs major bucks, and it also would weigh too much. So what we're going to do is we're going to actually put gold leaf on it. This process is called gilding. So what we do is we take this 8 ounces of gold and we hammer it out to equal a width of about 8 atoms, and at that we can actually make it look like gold. I've been told you can take gold leaf, hold it up at the sun, and you can see the sun through it, so it has some transparency. But then they very carefully hammer it out over the object that they're trying to put it on. when Notre Dame wanted to do this with gold, they actually figured out that the gold price would be $109,000. That's this thing. And then to actually hammer it out, it would cost exponentially more than that. So they nixed the whole idea and actually used a different material that's a lot cheaper. Probably even ended up spraying it on there. But since this is Forest Park, we want to be able to use solid gold. Solid gold is called 24 karat. 24 karat is 99.99% pure. If I take you down to this graph right here, this graph actually looks at 24 karat gold as being 99.95%. 22 karat gold goes down. If you take half of that, you're down to 12. That's a 50% gold. Merit wedding rings are right around 42% gold. They usually have something in there because you don't want to actually be able to hit this thing up against a wall and it start hammering it out because it's very malleable. If you try to make a ring out of solid gold, it would cost a whole lot more, and it also wouldn't hold its shape, probably even dent. Every time you hit something, you'd knock off a piece of gold. So they actually use 10% for jewelry, wedding rings. Other jewelry may be 12 or 14 karat. You can get 22 karat, and you can also get 24 karat. But let's say you actually want to put 24 karat gold leaf on top of this structure, but you have a builder, contractor that has no scruples. Let me give you an idea what your builder may look like. If you ever see a builder that looks like this, or a contractor that looks like this, and he shows you his teeth, and the teeth will have either really cool indentions in them, or they have diamonds, a couple of diamond rows, 4 diamond rows, or even have the more modest, this type of outlook. Can't really see, but it looks like he's got diamonds in his teeth also. He's got a whole lot of bling. If you actually see a builder contractor that looks like this actually came from a website, and they called this guy a moron, and actually about 80% of the people actually agreed with him. He's driving Mercedes-Benz that actually is already gold leafed. Okay, and let's say you actually hire him, and what he does is he actually picks, let's say 14 karat gold. 14 karat gold looks like gold. What it is, it's 50, almost 60% gold. It's almost 40%, 33.76677776666 on repeated. Percent something else. So we're actually going to take this gold. He's going to take this gold. He's going to charge you for this. So he's going to do this, and I want to know what is my percent error. Well, if you take a look at it, what do you get? You're going to be getting 58%. You're supposed to be getting 99.95. I'm going to round that to a nice 100%. And then we have to divide this by 100%. And then we have to multiply this by 100. So this, and also this is also an absolute value. So every number that comes out of here, regardless if you've got a negative number up here, a positive number, it's an absolute value. It's always going to be a positive percent error. I may have you actually tell me if it's a positive or a negative, but normally percent error is regardless of sign. So this is just going to be 42 over 100, which we all know is 42%. So if you actually paid for 24 karat gold and you were given 14 karat gold, you have a 42% error. You can do the same sort of thing. If I actually take a look at it, $63,200 for the 58% gold if we would have done this, $109,000. And if we do the same sort of thing, we find out that we actually have the same percentage. But anyway, our number is 42% wrong. That is our percent error. That would be unacceptable. But how else does this guy get all of his bling? Thank you much. Bye.